This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
As you all know, Master Brewers is a nonprofit organization. You probably also realize that it's expensive to produce shows like the Master Brewers Podcast every week. If you're a vendor, please consider sponsoring the Master Brewers Podcast. It'll cost you less than you probably spent to sponsor that last district meeting, and your message will reach the thousands of brewers who tune in each week. Click contact from masterbrewerspodcast.com to learn more.
You'll feel frustrated as a brewer that I've paid money, I've spent time in the process to dose this, and I'm still not getting the results that I'm supposed to get.
This week on the show, we're talking about one of the most timeless and popular fining agents in the industry, Isinglass. You'll learn how it works, how to optimize your results, when and why to use auxiliary finings such as silica solutions, and more. Here's today's guest to guide us along the way.
Hi, my name is Andrew Fratianni, and I am the Senior Brewing Application Specialist for DuPont Industrial Biosciences, where I look after enzyme applications in brewing and distilling.
Isinglass sometimes gets a bad rap. I'm conjuring up a scenario you've probably encountered more often than I have. That is, a novice brewer grimacing and asking why anyone would want to put fish guts in beer. Let's start with a reality check. Tell us what Isinglass really is and where it comes from.
Well, Isinglass is a collagen, and it is being a collagen is a very specific type of protein. And the isinglass that has traditionally worked in the brewing industry and worked the best, it comes from fish. So this is something that's harvested. It's a natural product and then processed. Basically, it's soaked in a dilute acid in order to extract the collagen, which then helps to clarify the beer. So I think people, when they think about it, or brewers, when they have that kind of reaction, probably don't have the entire story or all the information about isinglass, where it comes from and how it's produced and how it's used.
That makes sense. It's been in use for quite some time, right?
Yeah, so for brewing, we have references that we can cite going back to at least the 1700s. It's also been used in cooking, and there are some references that go back even 200 years prior to that. So we're looking at the 1500s. It could be, again, being a natural product, and isinglass that we use comes from the swim bladder of fish, which is a sack or a container. I think it's easy to imagine that thousands of years ago, it was first discovered that this was very good at a crude vessel for holding food or liquids.
Tell us about the structure of isinglass and exactly how it clarifies beer.
Okay, so right, in general, isinglass, I think most brewers would know it has a positive charge and it removes yeast. Yeast has a negative charge. But the isinglass itself isinglass has an overall net positive charge. However, if you look at isinglass, it contains areas of both positive charge and negative charge. So it's able to adsorb or bind to yeast with a negative charge, but other sites along the isinglass can still bond with positively charged proteins. So protein generally has a positive charge, but there are many smaller sites, and it depends upon how finely you look at these particles. So that's what allows it to bind other particles in the beer with multiple charges. I think another part that's interesting in understanding isinglass is that, again, this is due to the collagen and the specific chemical makeup of the particular type of collagen that's used for isinglass. Keeps it very rigid. It doesn't change its shape easily. It doesn't bend or deform. So what happens, I imagine, traditionally it's called a net, and a net that catches other particles as it falls down through the tank. But to me, in my mind, a net is made up of rope. It's rather soft and pliable. In reality, the isinglass doesn't appear to be that soft and pliable. So by maintaining that rigid structure, all those many sites that are both positively and negatively charged never become fouled or bound up in other particles. They remain rigid and open and available to bind to other particles in the beer. So I think that's makes it quite interesting.
Something unique about isinglass is that it works really fast. You can get bright beer in as few as 1 to 4 hours. Why is that?
Well, again, I think before we knew a lot about brewing science, we just knew that these things worked. And I think for isinglass, and now we're talking specifically about cask beer production. So before large breweries, before the invention of filtration that we know today, brewers found out that this works. And again, I think this is linked specifically to isinglass that comes from swim bladders of fish. There's always, if you read about isinglass and if you get the product information from your supplier, you have to be very careful not to let it get too warm. Otherwise, it will denature and turn into gelatin. Now, gelatin is widely available. A lot of home brewers and small brewers do use gelatin quite successfully for fining and clarifying their beer. And gelatin is also used quite extensively in the winemaking industry. But based upon what I've read, my guess is that for cask beers, isinglass was found to give a very short settling time and allowed brewers to clarify the beer in a 1 to 4 hour time period. So I think that's the advantage of isinglass, and that's really a specific application where it does such a great job. Even though you have other types of gelatin available, I think traditionally isinglass for cask beers gave the best results. The other part was the transport. So the isinglass would be added in the brewery, had to get transported to a pub. It would settle again very well. And I think that's where another type of gelatin, maybe mammalian-based, would not perform as well.
How about those the clarification times? What can you expect in a larger vessel?
In a larger tank, yes, I think the clarification, the settling time is going to be much greater. So if you think about a particle on the surface of the beer falling to the bottom of the tank, it has a much greater distance to fall, and it will require a longer time, even though the settling velocity might be the same. And that's where I think for clarification and in other parts of brewing, Stokes' law really helps us to understand what's happening in there. And basically, Stokes' law says that the settling velocity, so how quickly a particle will fall to the bottom of a tank, is governed by the particle diameter and the liquid density in the tank. So the larger you make the particle, the faster it's going to fall in a tank. And then that's where isinglass and other fining agents help to make larger particles.
The bigger they are, the harder they fall, right?
That's it, exactly.
All right. Another unique quality is that isinglass has been observed to improve foam stability. Tell us how that's possible.
Well, we know that it helps to remove phospholipids that are in the beer. So again, phospholipid is containing some fat or oil, which we know is foam negative. The exact mechanism for this, as far as I can tell and reading through the papers, still is not clearly understood. So although we know it works, we don't know exactly how it works. And interestingly, on things like isinglass, which have been around for so long, and people think that's old and there's nothing new to learn about it, there are still quite a few areas where we don't understand everything. So if there are any aspiring brewing students out there, there's a lot of topics that are ripe for further research.
Coming up,
you really need to do some optimization trials before you start using it in your production. So you want the highest clarity at the lowest amount of sediment with the lowest dose rate. So you have to balance all three of those factors.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. Here's what's coming up on the Master Brewers calendar. District St. Louis meets at O'Fallon Brewery on February 15th. The Fundamentals of Cut and Stack Labeling webinars February 19th. District Rocky Mountain meets at AB in Fort Collins February 22nd. District Philly will be at Trogs February 23rd. District Milwaukee and the Wisconsin Brewers Guild hold a joint technical conference March 1st and 2nd at Badger State Brewing. District Mid-South meets at Mill Creek in Nashville March 2nd and 3rd. District Northern Rockies meets in Bozeman March 2nd. The District Midwest Spring Meeting is at Mad Tree Brewing March 10th. Districts Michigan and St. Louis both meet March 15th. And check out the speaker lineup for the 2018 Eastern Technical Conference March 23rd and 24th in Atlantic City. View the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show. You wrote that silica solutions are often used in conjunction with isinglass as auxiliary finings. Anything you'd like to describe or add there?
Well, one part to keep in mind, and it's probably hard for everyday brewers to even get this kind of information, is the particle distribution. And this comes up a few times if you read the literature on isinglass. For the isinglass to work properly, you need to have a very specific particle distribution. And they're talking about things that are less than 2 microns, between 2 and 10 microns, and greater than 10 microns. And there should be a fairly set range in those categories for isinglass to work well. So the next question is, well, what if I don't have a particle distribution within that recommended range? What can I do? That's where the auxiliary finings come in. So there are a few products out there that are used to help clarify beer, silica gel, perhaps PVPP. I don't mean perhaps it's a fining aid, but perhaps it could help work in this specific application, and some other things that will help basically reduce the amount of particles and most likely get it into a more optimum particle distribution range. The thing to keep in mind is that isinglass should be used last. That should be the last fining dosed into your beer. So anything else you use should go in first. It could include also just carrageenan added into the kettle. It could include auxiliary fining agents added post-fermentation, so during storage of the beer. But whatever you use, that goes in first. You do not mix it with your isinglass and dose those together if you are doing that in a cellar. So add those first, make sure they're mixed into the beer well, and then you add your isinglass, and that should give the best results.
How can a brewer tell whether or not they've got that correct particle distribution?
In all my years of brewing, the only places doing particle distribution analysis are large labs, whether it's a brewing lab or an outside lab. So I think it is difficult at best to be able to do that kind of analysis. I would suggest start with your supplier first, and that's something I wanted to touch on as well. It's simply not a matter of taking isinglass and dosing it in and saying, okay, it worked or it didn't work. You really need to do some optimization trials before you start using it in your production. And the optimization trials will help you find out what is the best dose rate for the beer that you are using it on. There are general guidelines that a supplier can provide to you as a brewer, but you still have to go back to the brewery and do these optimization trials on your own, because you could find that you're dosing way too much, so that's wasting money if you're dosing too much, or you could find also that you're not dosing enough. So you'll feel frustrated as a brewer that I've paid money, I've spent time in the process to dose this, and I'm still not getting the results that I'm supposed to get.
Makes sense, and that's really true for any kind of findings, right? I mean, pretty much any findings, you really ought to be doing an optimization trial to find out that magic dose point for that particular brand, right?
Yes, and they're fairly easy to do. I think every brewer should know how to do it and should be able to do it on a regular basis. And you should do it at the very least yearly when you have a crop change with your malt and also with your hops. If you go online or to your supplier, there are videos on YouTube available. So suppliers sometimes have links on their websites, or you could just go ahead to YouTube and type it in the search, and they'll walk you through what is required to do some optimization trials. You take one beer stream or you take one wort stream, you add different doses, so different dose rates in, say, 4 or 5 different samples of the same wort, and then you just wait and let it settle. So this is something that collecting wort, preparing your solution and dosing it and looking at the results is maybe 1 day, 2 days at the most. And you'll need maybe just a few liters. You just need some small sample bottles to do this. So not a big demand on time.
Yeah, I've done it a few times. It's really, really pretty simple. I mean, you just need, whether you're using graduated cylinders or little like sterile sample bottles or whatever, and just take I've used a fluorescent light that you can get from Walmart or whatever, and put a piece of black electrical tape across it, and use that in the background, to judge the samples too. So I mean, it can definitely be done on a budget, and it's not hard to do.
No, it's not. So you mean making a light box to look at the clarity? Yes. Yeah. And I think actually Charlie Bamforth, in one of his MBAA papers, and it's probably on Hayes, describes how you can make a very inexpensive box like that in order to assess clarity. And it's visual. It's at this point, you're just looking at visual clarity. If you have other instrumentation and you want to do some more in-depth analysis, you can do that as well. The other part is just, how do you know what is enough, right? So the idea is that you want a bright wort, and that's going to be somewhat different for each brewer, but I think we could all agree there is a certain range if we're talking about bright wort. The other part is you don't want to produce too much sediment, or what would be called fluffy bottom. So you could overdose. You can get a very bright, brilliant wort or beer, but you have too much sediment. And of course, too much sediment means there's going to be higher losses. So that's you're finding that balance between clarity and sediment. So you want the highest clarity at the lowest amount of sediment with the lowest dose rate. So you have to balance all three of those factors.
What would you say are the main findings that compete with Isinglass, and maybe talk about where Isinglass either outperforms or underperforms against those alternatives?
Well, I think you have to look at it more of being part of a lot of tools available to the brewer to produce bright beer, so to produce a product you're looking for or eliminate haze. So it can't be any one product or any one step in the brewing process that takes care of the problem you want to eliminate. You really have to look upstream all the way to your malt and your brewing practices to, after isinglass, of course, would be perhaps some type of filtration and packaging. So it's isinglass, very good at removing yeast. So that's one type of haze you could have. But then you also have chill haze, which is protein polyphenol. So you could look at other fining agents to remove proteins or polyphenols. So I don't think it's saying one or the other, but it's looking at what's available, what your process is, what the limitations are, and what you can do within your process, how you're treating your beer, and what you want that beer to look like. And all of it's really geared towards being able to do this consistently and to do it efficiently, economically, so not wasting money or beer in order to get the finished product that you as a brewer want to have in the hands of the consumer.
Obviously, much of the growth in this industry has been and will continue to be in the small neighborhood taproom breweries and brew pubs, and a lot of those folks can't or don't want to filter their beer. For the small craft brewer who has never used Isinglass before but would like to give it a try, how do you suggest they get started?
Well, I think you probably need some samples first, or if a sample is not available, you can get small size available from your supplier. Again, there should be some protocol, some instructions on how to use it. Some isinglass comes ready to use, depending upon which country you live in, how far you are from the supply, or also freeze-dried. So you just have to mix that with some water. I imagine give it some time to hydrate, and you could dose it into your beer. So there are, for a small-scale brewer, there are definitely ways you can get started, do some trials, and see if it works for you or not.
That was Andrew Fratianni here on the Master Brewers Podcast. Do yourself a favor and read Andrew's article in the Master Brewers Technical Quarterly. You can get there from the publications menu or by typing Isinglass into the industry's best search bar at mbaa.com. As you all know, Master Brewers is a nonprofit organization. You probably also realize that it's expensive to produce shows like the Master Brewers Podcast every week. If you're a vendor, please consider sponsoring the Master Brewers Podcast. It'll cost you less than you probably spent to sponsor that last district meeting, and your message will reach the thousands of brewers who tune in each week. Click Contact from masterbrewerspodcast.com to learn more.